Okay, today we're working on lesson 8, and the opening exercise we're not going to do. Got a little bit of a different plan, so you don't have to worry about this stuff. But I would like you to write the goal here. We're going to solve problems, story problems, by writing equations. So in the past, you have kind of just reasoned through and kind of did the math that you thought you were supposed to do, and today we're going to take those pieces from the story problem. We're going to write a 1 or 2 step equation, and then we'll solve it. We've been working on solving equations for a couple weeks now. So be open to that, and let's see how it works. All right, so example number 1, Julie, Keller, and Israel are volunteer firefighters. On Saturday, the volunteer fire department held its annual coin drop fundraiser at a streetlight. After 1 hour, Keller had collected $42.50 more than Julia, and Israel had collected $15 less than Keller. The 3 firefighters collected $125.95 total. How much did each person collect? So this is a pretty intense problem. We have a lot going on. So what we're going to do is we're going to find the solution using a tape diagram. I'm going to show you how that works. First thing we're going to do is write down the 3 people that are in the story problem. After that, we're going to make a rectangle next to each of those people of equal size. This is going to be the beginning of our tape diagram. Next, we're going to look back for important information. We see that Keller collected $42.50 more than Julia. So what does that look like in our tape diagram? We're going to find Keller, and each of these rectangles represents an amount that they collected at the coin drop. So we know that Keller collected more. So we're going to extend out his rectangle because he collected more money than Julia. How much more? $42.50. So we're going to write that in there. What else do we know? We know that Israel had collected $15 less than Keller. So Israel, we know he collected more than Julia as well, but he collected less than Keller, so we're going to add to his tape diagram. We know that he collected $15 less than Keller. So this space here is 15 less. So if we do subtraction, we do $42.50 minus 15. That's going to tell us $42.50 minus 15. That's going to tell us that Israel's amount here is $27.50. So let's see if we're understanding this so far. We know that Keller collected $42.50 more than Julia. We don't know how much she collected. And we know that Israel collected 15 less than Keller, so that's where we did that minus 15 and got the $27.50. Another thing we know is that altogether, these 3 people collected $125.95. All right, so let's go ahead and use this tape diagram. It says, what are the operations we use to get the answer? But we didn't get the answer yet. So let's take a look. This is the question I'm looking at. This is really another way to look at an equation. So if I take out this little illustration here and I put in an equal sign, we have an equation with 2 sides, just like we've been working with. It's just in picture form. So these amounts are unknown, right? They're all the same, but they're unknown. So what we're going to do here is get rid of stuff that we don't need. So first thing we want to do is we want to get rid of this $42.50. So on yours, you can cross it out. I'm going to erase it. But if I erase or take away $42.50 on the left-hand side, I also have to do it on the right-hand side. So over here, I'm going to take away $42.50. We'll use the calculator. $125.95 minus $42.50 is $83.45. Okay, so we're getting closer to the answer. These x values over here, they're not alone yet. We have to get rid of that $27.50. So I'm going to erase $27.50 here. And if I do that, I also have to take away $27.50 over here. So $83.45 minus $27.50. It's $55.95. So our problem's simplified now. Our variables are alone. So if we look over here, we see that there are 3 x's, right? All of them are the same value. All of them are the same size tape diagram. And together they all equal 55.95. So really what we need to do is we need to divide this 55.95 equally to those 3 sections. So 55.95 divided by 3 is going to give us the solution. It's $18.65. So each of these values is $18.65. All right, so now we kind of need to go back because we know what the x value was. We know what Julia collected now. She collected $18.65. Don't forget that Keller collected $42.50 more. Let's answer this question. Julia collected $18.65. Keller collected $18.65 plus $42.50. So he collected $61.15. And then we know that Israel collected $27.50 more than Julia. So Israel collected $18.65 plus $27.50. So $46.15. And all of these together should equal a total of $125.95. So we can check that quickly. That would be $18.65 for Julia, plus $61.15 for Keller, plus $46.15 for Israel, for a total of $125.95, just like it's supposed to be. So obviously it's an intense process, it's long, but that's how you use a tape diagram. So what operations did we use? We used addition. Actually, we used subtraction and division. The amount of money Julia collected is J dollars, so we're going to pretend that we don't know the amount. Write an expression to represent the amount of money Keller collected. So this is like the other day when we were writing expressions. We know that Keller collected more than Julia, right? So if we take a variable, J represents Julia's money. We know that Keller collected $42.50 more, so it's just Julia's money plus $42.50. Just practicing writing expressions. All right, so it says using the expression for Julia and Keller, write an expression to represent the amount of money Israel collected in dollars. So we're going to use the same expression we just wrote, Julia plus $42.50, and that was the way that we show Keller's money. And then we know that Israel collected 15 less than that, so all we're going to do is add on a minus 15. And this expression would give us the money that Israel collected. Using the expressions written above, write an equation in terms of J that can be used to find the amount each person collected. So now what we're really going to do is we're going to take that tape diagram, which was time consuming, and we're going to write it into an expression instead, into an equation instead. And then we'll solve it. I'm actually going to show all the work down here because there's more room. All right. So what did we use to represent Julia's money? It was J. Okay. The expression we used, and I'm going to label this is Julia. The expression we used to represent Keller's money was Julia plus $42.50. So we're going to do Julia plus $42.50. That's Keller. Okay, that expression represents Keller. And then we have Israel. And here is Israel's expression. So his is Julia's money plus $42.50 minus 15, which would be, if we simplified it, Julia's money plus $27.50. Okay? So that one is Israel. What we're doing now is we're taking that picture and we're writing it algebraically. So J is Julia, J plus 42 is Keller, and J plus 27.50 is Israel. We know that all together, those are going to equal the total of 125.95. So as you can see, that was quite a bit quicker than drawing a tape diagram. Now we're going to combine like terms, and we're going to solve the equation. Okay? So here's what we practiced the past couple of days. We have 3 expressions here. We need to combine all of our like terms to make it easier to deal with. So let's look at the variables first. How many variables do you see? 1, 2, 3, right? So that's 3J. And then you have 2 constant terms, 42.50 and 27.50. We're going to add those together. 42.50 and 27.50 together are $70. So we're going to simplify our 3 expressions that we had into one expression, 3J plus 70. And that's still going to equal 125.95. All we've done is taken our 3 people and put them into one expression instead of 3 separate expressions. Now we have a 2-step equation. Remember, we're going to add and subtract to get rid of the constant. So the first thing you would do is take away 70 from both sides. When you simplify, you're going to get 3J equals 55.95. And now we have a 1-step equation. 3 times J, we're going to do the opposite. We're going to divide by 3. And we're going to get J, or Julia's money, equals 55.95 divided by 3, which should be the same answer we got before, 1865. Okay, the video is going to be coming to an end here. I want you to try example 2, and we'll be coming together as a class to try example 2 as well. If that one's too difficult, we'll write one together that doesn't involve fractions, because I see example 2 does have fractions in it. All right, so give it a try.